Today we're going over section 13.4, and the essential question is, how are inverse trig functions used? So we'll go back to the regular trig functions, and regular trig functions are used to solve a right triangle for a missing side length. So remember, those are the sine, the cosine, and the tangent. And you can see I have a triangle right here with an angle of 27 degrees, and I'm looking for the opposite side, which is labeled x, and I know the hypotenuse. That's going to lead me to using the sine function. So I have the sine of 27 degrees is equal to x over 5, because x is the opposite side and 5 is the hypotenuse. I'm going to put the sine of 27 over 1, and I'm going to cross multiply, getting x is equal to the 5 times the sine of 27, which happens to be 2.27. Okay? Inverse trig functions are used to solve right triangles with unknown acute angles. So really, the inverse trig functions are used to find angles. So you can see we have the same triangle over here, except we're not given the angle and we were given two of the sides. So again, I'm going to use the sine of theta, and that's going to equal 2.27 divided by 5, opposite over hypotenuse. Now, in every operation that we've had, we always have an inverse operation. Like to undo a square, we square root it. Okay? And so what we're going to do here is we're going to take the inverse sine of both sides. This inverse sine cancels out the sine and leaves you with only the angle theta, and this is what you plug into your calculator, making sure that your calculator is in degree mode, and you should get out 27 degrees. Okay? Moving to our third example, it says use a calculator to evaluate in degrees and in radians. So we want to make sure our calculator is in degrees, and I'll get my handy dandy calculator here so that you can see. And I'm just going to tilt it a little bit so you can see, and I'm going to type second sine negative 0.7 and press enter. And then notice that I get negative 0.78. Okay. That answer doesn't really seem reasonable to me, so I'm going to check my mode. Okay? And if I go back to the mode, I see that I'm in radians. Okay? So my radian part is already done, and I'm going to switch to degrees and go back and do the same thing again. If you have a graphing calculator, I could just press enter and it would change to my degrees. So negative 44.43 degrees. Okay? You need to be able to toggle between the modes. So you hit your mode key and you can choose radian or degree. I'm going to stay in degree mode because we do more things in degrees than radians. So again, before I told you that if you had a decimal in radians, you had to label it with a radians label. Degrees should always be labeled with this degree symbol. Okay? Our fourth example says to evaluate without a calculator in radians and degrees a value. Okay, before we do this example, I'd like to just explore this. And what I've done here is I've drawn a coordinate plane where this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees. And I've drawn the four angles that have a reference angle of 30 degrees. They are 30, 150, 210, and 330. Okay? So these are 30, 60, 90 triangles, and notice that the side opposite the 30 degree angle is always 1. And the side adjacent to the 30 degrees is always the square root of 3. Hypotenuse is always positive 2. Okay? And for each one of these quadrants, we're going to list the sine, the cosine, and the tangent. In the first quadrant, notice that they're all positive. So the sine of 30 is 1/2. The cosine of 30 is the square root of 3 over 2. And the tangent is 1 over the square root of 3. which we changed to the square root of 3 over 3. When I go into the second quadrant, it's 150 degrees, and if I find the sine, it's 1/2. The cosine now is negative square root of 3 over 2, and the tangent is negative 1 over the square root of 3, which I changed to negative square root of 3 over 3. Going to the third quadrant, you can see that the sine is negative 1/2, the cosine is negative square root of 3 over 2, and the tangent is 1 over the square root of 3, which we changed to the square root of 3 over 3. In the fourth quadrant, the sine is negative 1/2. The cosine is the square root of 3 over 2, and the tangent is negative 1 over the square root of 3, which changes to negative square root of 3 over 3. Okay? You will notice that the sine is both positive in the first and second quadrant, okay, and it's negative in the third and fourth quadrants. Now, this problem says it wants the inverse cosine of the square root of 3 over 2. It could potentially be two different angles. So that we get unique answers, we restrict the domain, okay? So we want to get all of the positive and negative answers for every angle. So for the sine, we're going to use the first and fourth quadrants. For the cosine, you'll notice the first and fourth quadrants are both positive. So for the cosine, we're going to use the first quadrant and the second quadrant where we have a negative. And for the tangent, we will use the first quadrant and the fourth quadrant, because we want to be as close as we possibly can to this positive x-axis and keep our angles as small as possible when we're finding these. Okay, so we're going to keep that in mind when we're doing our problems. So for this cosine, we're looking for an angle in either the first or second quadrant, and we're going to discard the third and fourth quadrants. So the square root of 3 over 2 leads us to a 30, 60, 90 triangle. So I'm just going to draw one here quick. Okay. And I know that the cosine is the adjacent over the hypotenuse, so I see which angle has the square root of 3 as an adjacent side, and it happens to be the 30 degrees. So if I'm drawing that 30 degrees in my unit circle, or in my coordinate plane, I know that I'm going to go square root of 3 to the right and 1 up, and 30 degrees will be my answer. Converting 30 degrees to radians will give me pi over 6. These should be coming easier to you, and you should be knowing those basic radian degrees now. Going to our next few examples, we have the inverse sine of 2. Now if I'm thinking of a sine function, it's the opposite over hypotenuse. And something that I might want to think about is, can the opposite side ever be longer than the hypotenuse? Because that's what would have to happen if I was going to get a number bigger than 1. The opposite side would have to be longer. That's not a possibility, so this answer would be undefined, since the hypotenuse is always the longest side. Looking at the second example, this says the inverse tangent of negative square root of 3. This leads us to believe that we're talking about a 30, 60, 90 triangle. So I'm going to sketch one here, a 30, 60, 90. Okay. I happen to know that This is the opposite over the adjacent. Okay, so I want my opposite side to be -3 and my adjacent side to be +1. Okay, so when I place that in a coordinate plane, I know that I want my 60-degree angle to either be in quadrant 1 or quadrant 2. So it's either going to be here or here. And I know that the opposite side has to be -√3. So a -√3 would be on the bottom side of your x-axis. Okay? So we would be thinking about an angle in quadrant 4. And this adjacent side would be 1 and the hypotenuse would be 2. So what angle, we could either write this as -60 degrees, and as radians, that would be -π/3. Okay. Looking at the third example, the inverse of -1/2. Again, I think we're talking about a 30, 60, 90 degree triangle because a 45, 45 triangle would be the square root of 2. So I'm going to draw this triangle again, listing out the sides. And I know that my 1 has to be negative because the hypotenuse is never negative. So the sine is the opposite over hypotenuse, and I know that I'm talking about a 30-degree angle. So when I draw my coordinate plane, I know that I'm talking about either an angle in the first quadrant or the second quadrant. Okay? And I know that the sine is always positive in the first quadrant, so I'm looking for something in this fourth quadrant. So when I draw my 30, 60-degree triangle here, I know that the -1 has to be opposite, and I'm looking at a -30 degrees, or a negative π/6. And it looks like that's going to conclude what we're doing right now. And so I'd like to give you a few problems to practice. If I can find the homework. I paused it.
Wouldn't it be funny if it's actually still big?
It's paused. No, it's not. It's not paused. How do you, obviously you can't do that. Okay. So anyways, we are going to do page 878, numbers 3 through 15, odd. Thank you.